Hi, I'm Bill Morrison, and this is Season 1, Episode 2 of Big Monitor Speakers in Recording Studios. Well, the reason we need big monitors in recording studios is so that we can really listen to the mix and what we're actually recording through its whole dynamic range. We want to be able to hear all the nuances and quality that's there, hopefully, so that we can see what we have. Normally, your noise floor in a recording studio or in a listening environment would be probably around 20 dB. And like the lowest SPL that you would have in your music would probably be around, it needs to be at least like 20 dB above there. So at 40 dB would be sort of the lowest point in the sound pressure level of the music. And then you want to have at least 80 dB dynamic range typically. So that would give you a maximum of 120 dB is what you need to really reproduce music and be able to really hear through the full dynamic range of the system. So it's really important to really demonstrate, the quality of your mixes and your recordings to your artists and people that are involved in the creative process. Also, it makes a great party speaker. It doesn't hurt that it's a high-resolution system, and people just want to celebrate. So, if you have a good system that's accurate and capable of high sound pressure levels, you need a big monitor system, and typically it needs big horns and big components. You can try to use cone and dome speakers, but they just won't reproduce the high sound pressure levels that you need without running into some sort of distress or feeling like you're trying to beat them up to get to the high sound pressure levels. You really need an effortless kind of monitor system that will get you there with full dynamics. So assuming you want a big control room monitor system, we talked about the Augsburger systems and Westlake systems that were used in the rock and roll era as being good systems, and we talked about how it's important to make sure that those are operating properly and are accurate. They have good first arrival accuracy. They're accurate in the frequency and in the time domain. Of course, accuracy in the frequency domain means that they're tonally accurate. It also means that they have low distortion, because obviously if you're generating harmonics or intermodulation products, those are not accurate reproductions of the frequency domain. And as far as time domain, you have to have accuracy in the time domain to have accurate phase response and accurate transient response. And it's also important in the imaging or the presentation of the sound stage that you're recording or mixing. So once you've achieved those in your system, we talked about ways to improve the system by changing to checking, first of all, testing to make sure all the driver components are working properly, crossovers and everything are working properly. And if there needs some corrections in them, substituting good drivers and incorporating a subwoofer, etc. But one of the big systems that was used quite a bit in European and in high-end applications was a system that was designed by Kinoshita, and this was sort of in cooperation with Tom Hidley. Tom Hidley designs famously included those monitors. Tom Hidley is the highest paid studio designer in the world. He famously designed BOP studios in South Africa. Actually, originally it was sort of an independent territory, and then post-apartheid it became part of South Africa. But that was a studio complex that cost upwards of $100 million. it was one of those situations where some government funds or some government pension plan or something over there decided a good investment would be to build the best studios in the world. And if you build it, people will come. And so it turned out they didn't really come that much, although Disney did record Lion King there, but it's really in a state of disrepair at this point, the last time I checked, with the original, large-scale mixing consoles and the facilities themselves really deteriorating. So the monitor systems that were incorporated in that system were the Kinoshita monitors. They basically were 15-inch TAD drivers, a mid-frequency and high-frequency horn, and then another 15 above that. And I'll try to splice in a photograph of that particular system because that's a good way to go, especially though if you use those components, because I definitely recommend, the TAD components. And then in the BOP studios, there were subwoofers that were supposedly went down to 10 hertz. I believe there were like 4 18-inch drivers on each side that would go down to 10 hertz. And those were all incorporated in his type of control room design, where the front of the control room was basically a massive, solid kind of concrete structure so that it wouldn't vibrate. And then the other areas of the control room were treated with very thick absorptive materials so that there was no reflection back to the engineer's position. And it was quite accurate at very low frequencies because the thickness of the absorption they employed really ensured that the low frequencies were also absorbed, as well as the mid and highs. I don't really believe there was much, very many reflective surfaces in there, although it certainly would have been possible to have some in there as long as they didn't reflect back to the engineer's position. But anyway, I'll put a picture of the monitors that were used in that particular situation. And then the TAD drivers that I'm recommending I've got over on this hydraulic table, and I really recommend hydraulic tables if you have big monitors, or else you need to have like a hydraulic back or a whole bunch of people helping you, because big monitors are very heavy, and the installation of them, it can be a little bit tricky because of the weight, especially if you're trying to mount them into soffits that are, up high at the wall. Now these components that I recommend, the TAD ones, are really the best components in the world. I've tested hundreds of other components by manufacturers from all over the world, and I haven't been able to find any that are as good or even are better than these TAD drivers. So if you can find them, it's really worth getting those. The story I heard was that the actual manufacturing of these was really interrupted because of the Fukushima nuclear plant problem that developed when an earthquake and tsunami hit Japan. So they're a little bit difficult to obtain, but you can find them new in the box, and you can find them used. So check them out to make sure they are operating properly and have not been abused. The great thing about the 2-inch compression drivers is, they have the beryllium diaphragm, which is they really haven't found any better material than beryllium to make for a diaphragm because of its lightweight, results in very low moving mass for the diaphragm and voice coil assembly. So it's it's an ideal diaphragm material. And another unique feature of the TAD compression driver is the phasing plug, in that compared to traditional, or really what's been available previously as far as compression drivers, is a phase plug that incorporates an additional waveguide in it, or it's a waveguide that's like a concentric formed waveguide, and I think there are like 5 of them in the waveguide or in the phasing plug. But the purpose of those is to make sure that the output from the diaphragm itself is phase accurate, because the diaphragm, because of the way it's physically configured, there would be different time arrivals from different areas of the diaphragm, which would cause phasing problems. So in order to correct those, they introduce these waveguides in the phasing plug so that the time arrival is corrected. So the diaphragm areas that are closer to the throat of the horn have to go through a longer waveguide, so that they arrive at the same time as on the edges of the diaphragm. So anyway, it corrects the phase accuracy of the diaphragm's output at the throat of the horn. And some people have speculated that that's one of the reasons why it is a better compression driver, but really it's a combination of the phasing plug refinement and the use of the beryllium diaphragm. The system that I have over here that we manufacture under the Biggs label is Diapolito configuration with a 1-inch compression driver on it. And the 1-inch compression driver has the advantage of it has very low moving mass, and because its voice coil is smaller and the actual diaphragm itself is smaller than, say, a 2-inch compression driver. In order to, because it is smaller, it won't handle as much thermally, as much thermal power as like a 2-inch compression driver. But since it's only handling a smaller spectrum of the music, assuming it's crossed over properly to mid-ranges that will go up to 1800 or so kilohertz, that's not really a problem as far as its power handling capability. So we use a 1-inch a lot of times in our systems with good results. So anyway, I wanted to, in the future episodes, talk about the accuracy, or how to achieve accuracy in the control room, and specifically talk about the use of absorption as well as geometry. So until episode number 3, I'll see you then. Thank you.